Hi, and welcome to another edition of SC21 TV. This one strikes close to home because this ubiquitous device, the smartphone, was developed in part because of all the discoveries in high-performance computing. But now this device is also changing the way that scalability occurs. We'll be talking more about that with my esteemed guest. Mehmet is just around the corner from us. I'm in Salt Lake City. He's in Golden, Colorado. Mehmet, introduce yourself, please.
Thank you for the introduction, Rick. I'm Mehmet Belviranli. I'm an assistant professor at the Computer Science Department of Colorado School of Mines. And my current research projects and areas are focused on applying my existing HPC expertise to mobile, embedded, and autonomous systems.
So when we look at our smartphones and you talk about traditional vertical integration, the smartphone and other small devices are affecting horizontal integration. Tell us what you mean by that.
So this is the definition of scaling is what we're going to talk about in this workshop and in this conversation. So when I want to start with an example. Apple's A12 series, they are the state-of-the-art system on chips right now. They embed more than 40 specialized IP blocks. We usually call them accelerators. And this is needed because those mobile devices are so powerful, but they can pack that much power into our pockets with very high operations per watt ratios. So this is an extreme example. And this is actually what we're going to be talking, how we will look into these developments, this diverse heterogeneity in mobile and embedded systems, and how we can exchange ideas between the HPC and those mobile and embedded systems domains, which are two different domains, and how we can exchange ideas and how we can apply one side's success to another.
This is not the topic of a short discussion, is it?
Yes, it is. Actually, we are going to spend half of the day, and we're going to bring experts from both sides of the domain, both from the mobile and embedded domain and the HPC, and we're going to have them discuss. We will have two keynotes, and we will have 6 panelists, and we will take the entire half of the day to discuss this.
So how has this come to be? I talked about, my mobile device, but this has been in the offing for a bit then, right?
Yes. So we have actually been discussing for a while in the HPC that we are approaching to the end of the Dennard scaling and Moore's law. So we need to specialize. We need to build processors that are very specialized on doing special tasks very efficiently. And yeah, mobile platforms are already doing that at a very extreme end. But even in the HPC domain, we started to see machine learning accelerators. Google CPU is a very nice example. And also CGRA-like architectures such as Xilinx Versal platform. So now in the HPC and large-scale systems, we are also trying to adopt this strategy. But it comes with challenges. First of all, the programmability challenges and portability challenges. How we program so that some parts of our application spans machine learning accelerators, some other part spans a specialized ASIC for a particular part of our application. And we call this horizontal scaling. Not only we span across thousands of nodes, but when we do, we also span multiple types of accelerators. That's the problem that we're trying to discover.
It's a good problem to have, right? Though, because it is related to the incredible power that is now at our fingertips and how to aggregate all that together in a way that still works.
Yes, I can actually give a recent example, a very popular example. Think about the edge cloud systems. And let's start with, again, mobile phones, right? Our mobile phones are powerful to do in-place operations like video transcoding and maybe machine learning inference. However, we still need to coordinate with those more powerful HPC servers when we want to do more complex operations, such as deep learning operations. We cannot do deep learning on our mobile phones. So, and when we want to implement such a scenario, we face several problems, such as how to distribute the workload, how do we communicate with the servers and the edge systems, energy efficiency, programmability, portability. These are the issues. And we can expand the number of examples. For example, medical IoT devices, they all need to be connected into big servers. And how do we program for those devices efficiently? That's the big problem.
So this kind of reminds me of some of the history of computing. If we go back to the IBM mainframes or the mid-range computers, the System 36s, they originally were dealing with just dumb terminals, right? But then you added in emulation cards, and suddenly you had PCs with computing capability connected to the mid-range or the mainframe, and it's a different level of complexity, isn't it?
Correct. Yeah, that's a very good example as well. If you think about the state-of-the-art supercomputers, top 5 supercomputers, they are indeed homogeneous. They have thousands of nodes, but they have only one type of devices that the developers need to worry about. But now the problem is in 2 dimensions, and we need to apply it. We need to think about it now so that the future systems will be ready by the time we have them.
Can you give us a more detailed preview of some of the areas of this workshop that you'll be exploring?
Yes, for example, we will have panelists, and some of them are experts in communication aspects of HPC, and they know how to distribute the applications. They know how to reduce the memory traffic, right? Communication problems, and these panelists are going to give us ideas about when we move into more heterogeneous platforms, when we scale in the vertical direction, what are the lessons that we can learn from such expertise from the HPC domain. And similarly, we will also have experts from the mobile and embedded systems. For example, we will have an FPGA expert who is working on synthesizing specialized workload blocks for commonly used operations, say convolution. So we will talk about the challenges. It will be mostly about programmability and portability, performance portability challenges. And we will see how those experts are dividing their workloads into multiple type of accelerators so that they can carry the computation in a very energy and performance efficient manner. And we have a lot to learn from them as well, because our future HPC systems will employ more than one type of accelerators. So we will try to ask both sides of the domain and see what about their experiences about the problem and how they can exchange such information so that when these 2 systems merge together, we have both vertical and horizontal scaling achieved, how we are going to tackle the new type of problems that we are going to face.
It sounds like it's going to be a don't miss workshop.
I agree.
Mehmet, a pleasure to talk with you in nearby Golden, Colorado. We'll look forward to seeing you in St. Louis in November. Thanks for being with us today.
Thank you, Rick. It was my pleasure to be part of this interview. Thank you.
And thank you to our viewers. Join us again soon for another edition of SC21 TV.